So quotient rule time. All right, so the formula itself is a mouthful. The way I learned it, though, is there's like a little expression you can have with it. All right, so we've got low and high. So it goes low D high minus high D low square the denominator, which is low, and away we go. So here, I'll go ahead and type the words too. Low D high, it autocorrected, minus high D low. Square the denominator, and away we go. So I remember it because it rhymes, the low and the go. I know I'm hyperfixating, but it is what it is. So the top is kind of similar to the product rule because we're doing a thing times the derivative of the other, and then the other thing times the derivative of the first. But we have a minus in between, and we have this extra denominator squared. So we're going to have to use the quotient rule a lot. We're going to use it when we get to our trig derivatives. So let's try it out. So we're told f of x is 4x squared, g of x is 3x minus 1, h of x is f divided by g, find h prime. So this means if we can define our derivatives, all right, so there's our f. So f prime of x will be 4 times the derivative of x squared would be 2 times x to the first. So f prime of x equals 8x. All right, then our g prime of x, well, this one's nice. So the derivative of 3x, the derivative of x is 1 times x to the 0, which is 1. So we just get that constant multiple. And then minus 1 with no x whatsoever becomes a 0. So our g prime of x is even nicer. All right, so now we're going to find h prime of x. So h prime of x. So low is g of x. D high is f prime of x. So low D high minus high is f of x. D low is g prime of x. Square the denominator, which is whatever the g of x is, and away we go. Now, when we do quotient rule, we very rarely are going to simplify these. It is generally just a do the dance, put the things in the spots, and done. Sometimes we'll have to work it out more, but most of the time we just don't bother. All right, so our g of x is 3x minus, here, let me actually use the colors. So 3x minus 1 times f prime of x was 8x minus f of x was 4x squared times g prime of x, which is 3, all over the squared denominator. Now, especially when the denominator's ugly like this, it is so tempting to be like, look, there's a 3x minus 1 and a 3x minus 1. They cancel. No. I want you to hear my very strong no. No. The only way to cancel is if we deal with the subtraction first. So we'd have to clean up the parentheses by multiplying stuff, then see if there's any like terms. Then we could try to factor the top and see if we would get a 3x minus 1. And most of the time we don't. So we're going to see with the trig stuff, like magic will happen on some of them and we actually will get some cancellation. But like here, if I go ahead and multiply it out, that'll be 24x squared minus 8x minus 12x squared. And if you do work out the top, just leave the bottom 3x minus 1 squared. Like whatever we're going to do with this algebraically, we would rather have the bottom like that. So 24x squared minus 12x squared is 12x squared. Ooh, I may have to eat my own words. Oh no, 8 doesn't come out of 12. No, we're good. So there, after all that crazy work, is our derivative in a slightly more simplified format. Technically, we could split it into 12x squared over the denominator minus 8x over the denominator. It is very rare to need to do that. This is typically a good enough answer. But sometimes even like here, like there is no derivatives. There's no primes. There's no ddx. Calculus is done. As far as I'm concerned, unless the directions say, and simplify, when the calculus is done, I have done what you wanted. You said find the derivative, there it is. All right, so this one we have straight up the ugly high and low, and they are ugly. So remember that square root of x is x to the 1/2 power. Once it's written as x to a power, we can do our power rule. Okay. So f prime of x, low d high, so low 7 square root of x minus 6 times the derivative of high. We'll have the 4 times, and then x to the 1/2, bring down the power. 1/2 x to the 1/2 minus 1 becomes negative 1/2. So let me just kind of here. This is d dx of x to the 1/2. Bring the power down. 1/2 minus 1 becomes 1/2 x to the negative 1/2. Now, if going through this whole process and thinking through like where the numbers move and then what do? It can feel like a lot, but we are going to use this all over the place from here to the end of calculus. So you want to be comfortable with your power rule and thinking through it. All right, so there is our low d high minus, and I usually make that minus really, really big because it's easy to forget about it. Now our high for square roots of x minus 5. And our d low, so that's going to carry the 7 times the same disgusting 1/2 x to the negative 1/2 over square the denominator and away we go. Calculus technically done. Webwork would probably be like, no, it's not simplified enough. I want you to be miserable. We did not write these problems. We found them into the database, thought they looked good. So, all right. So this crazy thing here is one term. Over here, the 7 square root of x minus 6 is 2 terms. So this is going to cause a distribution here. So I'm going to have the 7 times the 4 times the 1/2, which is 7 times 2, 14. And then square root of x times x to the negative 1/2, which is the same as 1 over x to the 1/2, or 1 over square root of x. So those two guys actually cancel. So it's x to the 0, which is, I'll go ahead and write it. And then here, minus 6 times 4 times 1/2 is 12. And then this will be x to the negative 1/2. Now I'm going to go ahead and keep some parentheses around that just to be safe. So around the first part, it's not going to make a difference, but the second part, you don't have these parentheses. And same idea, we got to distribute to both of these crazy terms. So that is 14, and it's another x to the 0. Great, my pen battery's low. Minus a very ugly 5/2 x to the negative 1/2. All over the denominator squared. So it turns out the 14x to the 0 minus 14x to the 0 is actually going to cancel out. Does happen sometimes. Particularly since what they were in terms of, they were both square root of x things, so. But here, that minus sign is going to need to get distributed. So I have negative 12 things minus 5/2, or sorry, plus 5/2. So that's 20, negative 24/2 plus 5/2 is negative 19/2. Of x to the negative 1/2 over 7 square root of x minus 6 squared. That's where I'd call it. We could do a little more rearranging, but it's not worth the effort. Okay. So we'll stop this one, and then I've got one more.